Hello everyone, I Ashka on behalf of our group would be explaining you our project on security system for cloud-based storage. So why do we use cloud? For the very fact that one can access files conveniently from anywhere over the internet. But is our data really protected? Our files are stored in a third-party server which is prone to being attacked or stolen. Therefore, protecting it is very important. Data is a precious entity. In today's fast growing digital age, people are adopting to cloud based storage for business and personal needs. The data stored by individuals and firms is confidential and needs to be secured. Our system, with the help of hybrid cryptography, achieves maximum security. So here's a big picture of how our system works. Firstly, the file is taken from the user, encrypted, and then uploaded to cloud. Now to access the file from cloud, the file is decrypted to obtain the original file. The encryption and decryption here is done using hybrid cryptography. So hybrid cryptography is a technique which is an amalgamation of symmetric and asymmetric cryptographic algorithms to create the best possible encryption interface for protecting files. Our system has utilized the combination of five algorithms, namely AES, Glowfish, Triple DES, IDEA, which is International Data Encryption Algorithm, and FERNET algorithm. So let's see how this algorithm works. So let's understand the encryption side first. Say you want to store a file in cloud. The given file will be split into 5 fragments. Each of the fragments will be parallelly encrypted using algorithms that we discussed previously. Finally, the encrypted fragments will be merged and uploaded to cloud. So now let's have a look at how the file is decrypted. The series of steps involved in this process take place in a similar fashion as that of encryption. The file is downloaded from the cloud and split into 5 fragments. Each of the fragments are now decrypted using the respective algorithms with which they were encrypted. The decrypted algorithms are then merged and voila, we can now access the original file. So, why do we use this method? In today's world, we want systems to be highly secure and fast, which is exactly what we are able to achieve with this proposed method. So, let's understand why this method is more secure than other traditional systems. The keys used for encryption are stored on the client's device. Hence, absolutely no one on the internet, including the cloud service provider, can access the data. Hence, making the system absolutely secure. This method is faster than other traditional systems. Why? This is because we have used symmetric algorithms which work faster while encrypting big files. We have also used asymmetric algorithms which are slow compared to symmetric algorithms but only for encrypting the key that is to be transferred, which is very small in size. Hence, due to minimal usage of asymmetric algorithms, we are able to encrypt and decrypt quickly. So what do we do if our cloud service provider wants to read the data? But we know that the keys are only stored in the client's local device. Therefore, the cloud service provider can access these keys through asymmetric encryption algorithm like the RSA algorithm. Here's the workflow of the software for encrypting a local file. So let's discuss the case where the keys are stored on the client's local device. The keys and the IVs are used to encrypt the segments of the file separately, which are randomly generated. These keys are then encrypted and provided to the user and stored in their local device. The segments that are combined are then uploaded, and the file is uploaded to a different directory than to the one in which the software is actually running. Devanshi will now explain the code and give the demonstration of our software.
Hello, I'm Devanshi and I'm quickly going to go over the important aspects of our code and then I will show a demonstration of our web app. So the main starting point of our code is the main.py file. Whenever we upload a file, this function encrypt input is called. Uh, as a part of it, the segment function is called. The segment function is described over here. What the segment function does is it breaks our text file that is to be encrypted into 5 equal chunks, and they are all to be processed later. So our text file has been broken down into 5 parts. After that, a gather info function is called, which is just basically gathering log information if anything goes wrong. It is not very much important. Then finally the hybrid crypt function is called. A hybrid crypt function is defined over here. What it does is it uses multi-threading to break it uses multi-threading to separately encrypt and parallelly encrypt all the chunks that we have created of our text file with different algorithms, and all these threads execute parallelly to make the encryption faster. Means all of them, all the encryption of the 5 segments are going on parallelly with different algorithms. The 5 different algorithms that we have used are called over here in the different threads, and the code that defines the function of these algorithms are defined over here. AES, Blowfish, then triple DES, IDEA, and Ethernet. All these encryption methods are defined over here. Uh, After the encryption is done, the file is then sent to the cloud on the backend, so that we can securely store it even if we don't trust the cloud provider. And after that, if we want to get back our original file, we will get we can fetch our file that we have stored in the encrypted form from the cloud provider, and we can decrypt it on our end. So this function decrypt message will be called whenever we want to decrypt our uh, file that we have fetched from the cloud. So the first function will be called, that is hybrid decrypt. That is defined over here. The hybrid decrypt function works in the same way as the encrypt function. It splits into 5 threads and decrypts uh, in the same way that it is encrypted, using the inverse function of the encryption, and uh, the inverse function of these encryptions are defined over here in the decrypt.py file. Okay, and then after the trim function then basically just collect the information like gather info, and at last the merge function is called, and it merges the we have our data in 5 different files that has been decrypted. Then we are going to merge it, and we will present it to the user. Okay, that was the basic algorithm of our code. The HTML files are uh, stored over here, and I will now be going on to the demonstration of our web app. So this is the home page of our web app. On the home page, as you can see, we have a browse button from which you can select a file that is to be encrypted, and then we will upload it. So let me press the browse button. So I have uploaded a txt file from my local system. The txt file is uploaded because right now we only support encryption of .txt type of files, but if the market is in favor, we can add support for other document types as well. So as you can see, I have uploaded a text file, and I am going to click upload and process. Over here we will press encrypt, and the encryption has been done successfully. We have uh, we have sent the encrypted file to a virtual cloud server that we have created virtually on the same computer, but in real life situations the file is to be sent to a remote cloud storage service like Azure, Google Cloud, AWS, etc. So the keys for decryption are not sent anywhere. They are stored right in the local system, so that we can ensure the safety of our files. So the keys that are stored, we can download them with this key over here, and with this key we can fetch our data from the cloud back, and we can decrypt our file to get the original file. So I will right now just click the download key to download our keys and see what they look like. The keys have been downloaded over here. I will go over them later in this video. Let me click the decrypt button now. It is showing that the file has been processed successfully. That it means that it has been decrypted, and we can download the file now. So there two files have been downloaded. One is original 6.txt. It may not be visible on the screen right now, perhaps, but original 6.txt and output 7.txt. Original 6.txt has the keys, and output 7.txt has the decrypted file back. So I will quickly open those two files. Okay, so this is the original text file that I uploaded to encrypt it on our web app. Then original 6.txt is the file that we downloaded for the keys. So as you can see, this is the key that is used for the encryption in the algorithms. And at last we have output 7.txt, which got downloaded when we decrypted the file back. So we have got back what we actually uploaded after encryption and decryption, so we can conclude that the software works properly. In this part of our web app, in the working tab, we have given a quick overview of how our software works. So this is the basic workflow. We get an input file that we need to upload. We will encrypt it on the client side, and then we'll upload the file in the cloud, which is stored in the cloud data server. Whenever we want our file back, we will fetch the file, and before exposing it to our client, we will in this yellow box we will decrypt the file using hybrid cryptography, and thus ensuring the security of our file. This is an overview of how the encryption particularly works. So as we discussed earlier, we have the file. We will break the file into 5 equal parts, and then we will encrypt it using 5 different symmetric encryption algorithms. Then we will combine all the segments that are encrypted using different algorithms, and then we will upload it on the cloud. And in the same way, while downloading, we will get the file, we will split it and decrypt it separately using different algorithms, and then at last we will merge it to give it back to the user. In the commercialization tab, we have thought about how to get this product in the market. So there are 3 types of users that we could think of. First is individual users. For users who do not entirely trust the cloud services, it would work as an extension in their personal browser, which can be activated when any interaction with the cloud happens. It will work as a kind of firewall and provide encryption and decryption at the client side of the application. The second class of users that we can sell our product to are businesses, small and big businesses. For businesses who store their confidential data on the cloud, we can provide them a personalized interface that fits their software model and that provides an additional layer of encryption on their side. The third and the last class of consumers of a product that we could think of is the cloud providers like AWS, Google Cloud, Azure, etc. We can establish partnerships with the cloud providers to integrate our software into their platforms, which could increase the reach and visibility of our product. We can also look into licensing our software to other companies that may want to incorporate our encryption and decryption technology into their products. And lastly, this is the about us tab. We are working under the guidance of Professor Manish Gupta. We are a group of 6 students, and we are studying Introduction to Cryptography course in DICT, and we are in third year. This was our short video about our project. Thank you very much.